Okay, so I have to go into this, and after I glue these magnets permanently to the surfaces, I wanted to make these all straight, but I didn't have any other magnets. So I had to jack my skateboard for magnets. So therefore I have two skateboards, which enumerates 4 permanent nickel neodymium magnets. That's the skateboard hubs. Those are the skateboard hubs. So I jacked my skateboard for the permanent magnets because they sent my package all the way to Jersey, and I couldn't get them in time. So I have these skateboard magnets, which I believe that this gauge of this motor, I'm not sure, this is probably a step up to, this is probably a 22 or 21. This might be a 22 AWG. I have a 20, this is probably a 22. I have a 24 AWG, which is lesser in gauge. And this is probably a 20, maybe a 23 or 22 gauge. And this is enough to move a human being on the surface of a wheel bearing, as far as motor hub. And according to the foot of the coils, so I think that's probably maybe like 60 turns. I don't know, it could be less than that. It looks like it's more like maybe like 35 or 45 turns. It may look like 35 turns, barely getting 35 turns. So I see how many layers did they make. I think that they made like 2 layers, maybe it's like 35 turns tops. I'm going to be winding these magnets up in a coil. I'm going to wrap the entire thing and flex it to the surfaces and drive it all the way around and flex it to the surfaces in the back, so that the permanent magnets will be enclosed in the solenoid field. Then I'm going to resin it with hardener, epoxy hardener. But before I do all that, I have to separate this by another sheet of metal. The sheet of metal that's under it, it's on it. I could separate it by another sheet of metal, or I could just use wax paper. My plan was, I can use wax paper. I made this hole. This is for the IRONMAN faceplate. I made this hole so I can apply a substantial amount of permanent magnets around here, so I can gain the induction from the permanent magnets to the coil, pancake coil that I'm going to make for the armature to actually receives induction, paramagnetic induction, and then emits eddy currents back to the surfaces. So it will be like a solenoid pancake driven by a regular DC phase motor. And while doing that, that will cause the rotation to be synchronized by the permanent magnet, and then sends the eddy currents back to the surfaces, against the surfaces. After it's wrapped, I'm going to have enough space to bulge enough space around a motor so that the armature sticks out, and I can really couple the pancake to it and cause it to drive around. And after I resin and epoxy resin the surfaces and apply the coil, and then apply the epoxy resin again, so that it synchronizes the induction and causes a linear motion, magnetic suspension like a voice coil. And that's going to be used like a speaker for a voice coil. And within the magnetic field, being the opposite side, on the opposite side of the coil, and cause it to oscillate. However, the synchronous will cause it to move up in a linear motion. So what I'm doing is I'm using the regular power for the magnets to power the system of the induction. And I might be using a single-phase wire diode to create such an effect. And I promise to add the a taser, because I want to have in here, I'm waiting for my other 3, 1, 2, and 3 for the center. I need to add ions, so I'm making a spark gap and creating the current so I can create a plasma charge. That's enough electrostatic and electrostatic gust within the magnetic field, the solenoid field, to move the faceplate in a linear motion, which is more than that, which is invisible, that is not seen carrying about the motor. But the repulsive force is electromagnetism uses a repulsive force. So the electromagnetism will use the repulsive force. Like I said, these are 4 motor hubs, permanent magnets, so it's very, very powerful and very strong, which is enough to lift like if 2 people ride on 2 skateboards, hubs, motors, which are 4 in enumeration, it's enough to power a 200-pound person twice. So 200 pounds, that's 400 pounds twice. Now, using a single-phase diode rectifier between the coil, so at the phase point of the coil, so I can have the current going one direction, and I'm going to add a capacitor within the coil, so the bypass the single-phase rectifier. So while it's doing the turns, when it receives the induction current from the synchronous charge, then it's going to build a voltage for the capacitor, and in constant sending the voltage from the capacitor outside and and a helix coil to move it upward like a magnetic suspension. So I'm going to make about 4 turns. One turn upward, which is a continual turn, consistent according to the metric range, and then a turn downward, then upward, then downward. So I'm going to do that 4 times. And I don't know how much coil, because I didn't measure the gauge of the coil is versus the distance of how long I'm going to be spinning it around here. So therefore, this embedded within it, this embedded here on the other side, and I'll just wrap it up and use aluminum cylindrical for a spark gap, so I can put 2 rods here and allow it to be separated so it can fire and create enough electrostatic within the center of the magnetic field. So, the solenoid holds sense. So hopefully I can get it to fly with using magnetic repulsive behavior. My name is Jermaine Morton. Goodbye.